Hello, Matthews Gatos here. In this video, we are going to cover the properties of linear functions. Let's get started. Linear function graphs. Any kind of a linear function, when we graph it, is going to produce a straight line, hence the name linear. So it's a function that has a constant rate of change from one point to the next point. Now, a rate of change is the ratio of the change in my dependent variable y to the rate of change of my independent variable x. If that is the same distance from point to point to point, it is a linear function. Let's look at this example here. So, well, clearly I can see it's a line, but how would I determine if it was in fact linear? I just look at how much am I going up or down, that's your y value, compared to left or right, and that's your x value. So I can see I'm going up 1 over 1, up 1 over 1. Since it's the same amount from point to point, I know this is a linear graph. This one here, you can clearly see it's not linear, but here's why. From point to point, I'm going up 1 over 1, and then I'm going up 2 over 2. So since the rate of change is not the same from point to point, this is not a linear function. Linear function coordinates, the independent and dependent variables, increase or decrease by a constant. That means same amount. Now the amount doesn't have to be the same increase for the independent variable as it does for the dependent variable, as long as it's consistent within each variable. Let's look at an example. Here I have a table of values. I want to know, without graphing it, is this a linear function? So I start with my independent variable x, and I can see I'm going 1, 2, 3, 4. I'm going up 1 each time. So I have a constant rate of change within my independent variable. Let's look within my dependent variable. So I'm going 1 and then 3 plus 2. 3 to 9 is plus 6, plus 18, plus 54. I do not have a constant rate of change within my dependent variable. This is not a linear function. Let's look at this. A collection of function can also be a collection of points. Let's see if it is a linear function. So again, look at your independent variable, your x values. So I can see I'm going from 2 to 4, plus 2, plus 2, plus 2, plus 2. Again, looks promising, but so did the last one. So let's see if it works for the y values. 7 to 10 is up 3, and then I'm doing plus 3, plus 3, plus 3. So since x, the independent variable, has its consistent rate of change, and y, the dependent variable, also has its consistent rate of change, they don't have to be equal to each other. This would be an example of a linear function. How do you recognize a linear function from the equation? Well, the independent and dependent variables can have an exponent of 0, meaning there is no x or y, or an exponent of 1. The independent and dependent variables cannot be in the denominator. If they were, that would be a negative exponent. And the independent and dependent variables cannot be exponents themselves. So let's see if the following are linear functions. Y equals 2x squared plus 7. Y has an exponent of 1, but you can see x has an exponent of 2. So this is not a linear function. Let's look at my next one. Y has an exponent of 1, x has an exponent of 1, so this is a linear function. In C, I have y equals 2 to the exponent of x plus 6. This is not a linear function because x is the exponent. That's not allowed in linear functions. And then y equals 3 over x minus 5. This is also not a linear function because x is in the denominator, which really means x has an exponent of -1. So again, for it to be linear, x and y can have an exponent of 0 or 1, and that is it. Now that I know what a linear function looks like from a table of values, coordinates, and equation, let's look at how do we graph using a table of values. So when you graph, you are going to choose values for your independent variable x. Now, if it's not a word problem, I really recommend choosing negatives, 0, and positives. So something like -2, -1, 0, 1, and 2. Those are good choices. You're going to substitute your independent variables into the equation and determine the corresponding dependent variable that goes with that. When you do that, you now have an ordered pair x, y, and you're going to graph those to produce the graph. Let's try an example. So I have this equation, y equals 3x plus 2. It looks like it's linear because x and y each have an exponent of 1. So to graph it, you can see what I did. I chose 2 negatives, 0, and 2 positives. And I just went in numerical order. -2, -1, 0, 1, 2. To find the y values that go with it, I'm going to take my x value of -2 and replace it here and follow the function rule. So for the first one, I'll have 3 times -2, which is -6, plus 2 is -4. So my first coordinate will be -2 and -4. So I'll put a little dot there. Okay, and my next one, -1. I replace x with -1. 3 times -1 is -3, plus 2 is -1. So I have another point at -1 and -1. I'll replace it with 0. 3 times 0 is 0, plus 2 is 2. So another point at 0 and 2. Replace it with 1. 3 times 1 is 3, plus 2 is 5. So my next point will be 1 and 5. And I can see this is definitely following a linear path. And then when x is 2, 3 times 2 is 6, plus 2 is 8. So when x is 2, y is 8. And you can see, I can even connect the dots. That is a linear graph. So I'll try and connect the dots on this. Oh, not a terrible job. And there I can see it is a linear straight line graph. Let's try a word problem. So we have a wedding caterer that charges $500, that's the flat fee, plus $30 a person. So I want to come up with the equation and identify the independent and dependent variables. So I'm going to use cost for my cost and P for the number of people. So my function will be C of P, cost per person, is 500 plus 30P. So I can look at this and see that my dependent variable, C, is the cost, kind of like a y value. Inside the function notation, this P here is the independent variable, and that represents the number of people. That's my independent variable. So I want to come up with a table of values. Now notice I didn't include any negatives because I can't have negative number of people. So when I choose the values for my independent variable, choose ones that make sense. So if it's an equation, negatives are okay. Word problem, it's not. So I chose to start at 0 and I just went up by 20. This is not the only choice you could have for your table of values. It's just what I chose. So for 0 people, I'm going to do the same thing. 500 plus 30 times P, which is 0. So that's going to be 500 plus 0 is 500. So 0 people cost 500. If I have 20 people, 500 plus 30 times 20, that's going to be 500 plus 600, which is 1100. And I do the same thing for 40, 60, and 80. Now that I've generated my table of values, I want to talk about rate of change. So rate of change we did on the graph. We also did that with our table of values. And a rate of change is just looking at the change in the dependent variable, which we know is C, over the change in the independent variable, which we know is the number of people. So for example, in the first one, I want to look at the rate of change between my dependent variable and my independent variable. So I would do 1100 take away 500 over 20 take away 0. And I get that that is 30. I can do it for the same for the next one, 1700 minus 1100 over 40 minus 20, also 30. And I can do it for my last two entries, and I am getting the same rate of change. That tells me this is a linear function because I have a constant rate of change from point to point. What it tells me in terms of the question is that the cost, the change from person to person, is $30, which we would expect right here. So this tells me that my price is going to increase by $30 for every extra person. So now we've seen linear functions as coordinates, graphs, equations, tables of values, and now word problems. So speaking of weddings, I once went to a wedding that was so moving, even the cake was in tears. Get it? Tears for a wedding cake? Good joke. If you liked this video, please give it a thumbs up and hit subscribe so I can help more mathies just like you. And I hope this video helped, and I look forward to seeing you for the next one.